Hi everyone, today I'm gonna discuss my stochastic calculus computer-based test question with you guys. So today I'm gonna discuss question 1 and question 7. Okay, so let's look at question 1. So LF Newcastle stock has a current price of S0, its annual volatility is 12%, and then the stock pays dividend continuously at a rate of 1%. The stock price follows the binomial model with 36 periods, 1 month each. The continuously compounded risk-free interest rate is equal to 7.4% per annum. So we are asking to determine the price of stock at zero. If the price at zero of a 3-year 42 strike American call option is equal to 10.93770181. So we just put this information into our Excel. So K equals to 42, and then this is American call option. R equals to 7.4%, and then our sigma is equal to 12%. Delta equals to 1%, and then binomial step 36. And because this one is 1 month each, so our time to maturity in year is 3 years. Then how to calculate our hedge? Our hedge is equal to 1/12 for each month. And then for U, D, and P naught, we are using this formula. So U is equal to exponential to the power of R minus delta times h plus sigma square root h. And then D is equal to exponential to the power of R minus delta h minus sigma square root h. And then P naught is equal to exponential to the power of R minus delta h minus D over U minus D. Okay, so after getting all this information, we are just putting using this information to construct the 3 tables, which is our stock price, our payoff, and our call. So because we don't have the stock price, so in order to calculate the stock price using the Gaussian function, and then for the table, we will just put all the formula first, then we're using the Gaussian function. Okay, so how to calculate the stock price? The stock price is for the next period is equal to S times U equals to SU. Then we times U again, we're getting SUU times D, we'll get SUD. Okay, the same method. For the down, we'll get if S times D equals to SD, okay, times D again, we get SDD. Okay, so how to construct this in our Excel? So using this formula. Okay, so look at this. Okay, so if F2 is equal to 0, so F2 is equal to 0 like this. Okay, we are using this more better. If G4 is equal to 0, okay, we are using G3 times D. Okay, if this is equal 0, using this times D. Okay, so if not using G4, okay, G4 times C10, okay, times C10. Okay, using G4 times D, C10 is for here, okay, or this, okay, how to say. So let's look at this. If G3 is equal to 0, then G2 times C11 for equals to G2 times 11, because this one is SU, SUD. Okay, so this one you have to times D. If not, using G3 times this one is also SDU. Okay, so makes sense, right? Okay, so we just construct all this formula for all the table. Okay, for all the 36 step table period. Then after that, we'll calculate the payoff. So the payoff is, because this one is a call option. So the call for a call option, the payoff equals to 0 if ST is less or equal to K. And then ST minus K if ST greater than K. So using the maximum formula. Maximum of the ST minus K or 0. Okay. So after construct the payoff, then how can we construct the call price for American call option? Okay, so we will put the payoff for the last period first. Okay, how to calculate the payoff for the last period for American call option? So look at this condition. So it's either the discounted payoff for next period or the payoff for current period. So we choose the biggest one. So we have this kind of formula here. So if the payoff for the next period plus together, and then we're using, because for C we're using the probability P naught. Okay, so the two payoff, the between the two payoff, and then we plus times back the probability, and then we discounted back with compared to this value, and then we compare which one is bigger. If this one is bigger, we choose this one. If the discounted payoff for these two is bigger, then we will choose this payoff. Okay, so the formula for here is equal to this. If exponential, the discounted, okay, this one is the discounted formula for the payoff for these two, okay, times P naught plus 1 minus P naught times AP41, okay, is greater than this, then we will choose this. If not, we will choose this, okay? After that, we just using this formula, and then we put for all the table, and then we can construct the price for this. We just put this price because this is given one. Okay. After that, we're just using the Gauss-Seidel function, and then we can calculate our stock price is equal to 45.5 at 42124. Okay. So let's move to the question number 2. By using the value of S0 in 1, question 1, construct a bathymetry with 12 period and each length of 1 month, then determine the price for a 1 year at the money European put option on one share of this stock. So at the money means that the K equals to S0. So our K is equal to 45.5 at 42124. And then because this is a European call option, we don't need to construct a table like question 1 because this is an American call option. We just need to calculate the value for the last period. So how to what is the value that we need in the last period? We can look at this formula. Okay, look at this formula. So only need to calculate the last binomial period, which is equal to the big T factorial over the small t factorial times the big T minus small t factorial, and then times P naught to the power of big T minus small t times 1 minus P naught to the power of small t times U to the power of big T minus small t, and then times D to the power of small t, and then times our payoff. Okay, we construct one by one. So the T, because we have 12 period, and then so the total T is equal to 12, and then we put that the small t is from 0 to 12, and then the big T minus T is equal to from 12 to 0. Okay, and then we calculate the U to the power of T minus T, and then times D to the power of small t, and then we have this column. And then how to calculate the stock price? So the stock price is equals to this, right? So we'll just putting it, because we have to calculate the last column. So in one time method, so we just calculate the ST. Okay, so look at this formula. This one is equal to this, the stock price, times this. Okay, times U and D. Okay, and then we have this column for the stock price. And then how to calculate the payoff? Because this one is a put option. For a put option, the payoff will be either K minus ST or 0. So K minus ST is if ST is less than or equal to K. If ST is greater than K, then our payoff is equal to 0. Okay, so we have this column. Then we just then we still have left one, the probability. So the probability is equal to P naught times T minus T, big T minus small t, and then times 1 minus P naught to the power of small t. Okay, and then after that, we just calculate the factorial. The factorial is equal to big T factorial over small t factorial times T minus T factorial. Okay, and then we just times these three columns together, the payoff, the probability, the factorial. Okay, and then we'll get the put price. Okay, and then we sum it together, and then we discount it back. We'll get the discounted put price is equal to 0.965301666. Okay, so let's move to the question 3. By using the value of S0 in question 1, construct a bathymetry with 18 periods and each length of 1 month. Then approximate the value of delta and gamma at time 0 for 1 year at the money. Okay, also at the money European call option on one share of this stock. So our S0 and K is equal to 48.5 at 42124. Okay, so as question 1, construct the call price table. So using the P naught, okay. So in order to using the P naught, we have to know the payoff first. So we have to find the last column payoff first. So for the payoff is equal to, because this is a call option, so it's equal to ST minus K, because we're using 18th period only, so we just look back to the 18th column. So 96.60649 minus the 45 point something. Okay, this is our K. And then we construct the last column first. And then in order to calculate back the call price, because using the P naught and 1 minus P naught. Okay, so if X134, okay, we will see this better. If X144 is equal to nothing, which is equal to 0, then we put a 0. Okay, if here, sorry, we get back to here more clearer. So if X134 is equal to nothing, then we put nothing. If else, we put X133 times our P naught plus 134, and these two value, and then times these two value. These two value will get this. Okay, so times 1 minus P naught, and then we discount it back, which is exponential to the power of negative r times h, we will get this value. Okay, because this is a decline table, so we need this condition here. And then we'll get the final call price is 5.10132111 at 1. Okay, then how to calculate the delta at time equals to 0? So delta equals to exponential to the power of negative delta h times CU minus CD over SU minus SD. So this one is our CU, this one our CD, and then our SU is equal to this SU SD. And then in order to calculate the delta, we have to calculate the up naught delta, the gamma, we have to calculate the up naught delta and down naught delta. So the up naught delta is equal to exponential to the power negative delta h times CUU minus CUD, CUD, and then SUU, SUD, and then divided by SUU minus SUD. And then the down naught delta is equal to exponential to the power of negative delta h times CUD is equal to this. CUD is equal to this minus CDD, and then SUD minus DD. And then in order to so for the gamma is equal to up naught delta minus down naught delta over SU minus SD. Yeah. So this is my presentation for question 1. So now let's move to question 7. So for question 7, Tamara Mellon, a London-based fashion designer, is expecting to receive 100 million from a Japanese company as payment for goods sold in 1 year. Concerned about potential exchange rate fluctuations, the company decided to hedge its currency risk by purchasing an option that grants the right to exchange yen for pounds at a rate of $0.0055 over yen, given the following information. Our spot exchange rate is $0.005 over yen, and then the volatility of the exchange rate between the two currencies is 0.08, which is 8%. The continuously compounded risk-free interest rate for yens is 0.055, and then the continuously compounded risk-free interest rate for pounds is 0.035. So we are required to calculate the cost of hedging using a 12-period volumetry using two distinct approaches, pound denominated and yen denominated. So let's move to Excel. So sorry for press wrong. So sorry. So question 7, wait for a while. Yeah. So for question 7, for pound denominated, because we are a London designer, so we assume that we is Beatrice. Okay, so for Beatrice, if we need a pound denominated, we have to buy a put option, and then our exchange rate at the current price is 0.05, and then our spot exchange rate, and then our strike exchange rate is equal to 0.0055. our sigma is equal to 0.08, and then our R is equal to 0.035. And then this is our domestic R. So it is equal to exchange rate to pound. And then this one is exchange rate to yen, which is equal to 0.055. And then our hedge is equal to 1/12. Okay. So because this is 1 month period, and then our U is calculated by this. So for exchange rate, our U is equal to exponential to the power of R domestic minus R foreign times H plus sigma square root H. And then D is equals to exponential to the power of R domestic minus R foreign times H minus sigma square root H. And then our P naught is equal to exponential to the power of R minus R domestic minus R foreign times H minus D over U minus D. Okay. So, wow. Okay. So, sorry, please wait me for a while. Sorry, just now I pressed wrong for the cans for the close. Okay, so now we move to question 7. So we have to construct a table for exchange rate and the put option. So the exchange rate is same as our stock table, stock price table. So which is using the U and D. So using the U and D, so we're just using the formula like question 1. Okay, the formula like question 1, and then we can construct all the table. And then in order to calculate the put price, okay, the put price we just using we have to calculate the last column for the pay offers, which is equal to, because this one is put, so it's equal to K minus S minus exchange rate or equals to 0. Depends on ST is greater than K or lower than K. Okay. And then we get this last column. And then for how to calculate the calculate back the put price is equal to this formula. Okay, we just discounted back the 2 column, and then we'll get this. Okay, discounted back this 2 column, we'll get this. Okay, so after that we'll get the put price is equal to 0.000592163. Okay, and then our cost of hedging is equal to 100 million times the put price. Okay, so for yen denominated, our spot exchange rate will be equals to 1 over 0.005, and then our K will be equals to 1 over the pound strike exchange rate. Okay, so which is equal to 1 at 1.818181. Okay, and then our R domestic will be changed because this is from the perspective of yen. Okay, so and then the R foreign also change to pound, which is 0.035. And then the sigma hedge, and then our UD P naught will be changed because our R domestic and R foreign has been changed. Okay, same as how we calculate the pound denominated. Okay, now we have to calculate the exchange rate for yen denominated, but now we calculate call instead of put, because assume as a Japanese exchange yen for pounds using call option. Okay, so our the current exchange rate is equal to 200, and then we're using the formula for U using U and D, and then we can construct the table like what we do previously, and then the call price using the calculate the last column for pay offers, which is equal to ST minus K instead of K minus ST. And after that, we can calculate these 2 payoff, and then we discount it back, and then we can get the get each period the payoff for the call price, and then we can construct it until the first one, and we get the call price. So the expected payoff. So the expected payoff is okay. No, this one is for question B. Okay. So the cost of hedging is equal to 100 million divided by our pounds, the exchange rate. Okay, our pound exchange rate equals to this because we are at the perspective of British, and then we times the cost of hedging is times call option times this, and then we get 11843258.57. Okay, let's look at the last question. To calculate the price of the option by conducting a Monte Carlo simulation of 100,000 interactions using Microsoft Excel, and then we assume that this is a Black-Scholes framework. Okay, so our x0 is equal to 0.005, k equals to 0.0055, r pound equals to 0.035, iron 0.055. This is our R domestic, R foreign, and then our sigma is equal to 0.08, t minus t equals to 1. Okay, so we just construct this table. So using the random number, and then in order to calculate the z-score using the standard normal, because we want to find back, so using the standard normal inverse, norms inverse. Okay, so for this random number, and then after that, how can we calculate the exchange rate? So the exchange rate for the next exchange rate is equal to x1 equals to x0 times exponential to the power of r minus rf, r domestic minus r foreign, minus 0.5 sigma square times t minus t, these are t minus t, plus sigma square root t minus t times z value. Okay, then the z score, and then we get this exchange rate. Because this is a pound denominated, so I will pay off using a put option. So pay off using put option, which equals to okay, wait. Okay, sorry, this one is using this. This okay. Okay, so we should use the payoff equals to k minus st minus our exchange rate, and then we'll get this one. Okay, and then our put price will be our expected payoff will be equals to the average of this payoff, and then our price of option is equal to our expected payoff times discounted back, okay, times exponential to the power of negative r pound, and then times t minus t, and then we calculate the 100 million, the put price is equal to 100 million times F59, this value. Okay, this is my presentation for my CBT. Okay, thank you for watching this video. Goodbye.